All right. So I think probability, last two questions were remaining. So let us complete them first of all. Question number 23. A game consists of tossing a 1 rupee coin 3 times. Okay. And noting, I think question number 22, second part was also remaining, right?
Yes, ma'am.
Hmm. Okay. So first let us do 22 second part. Now they are saying, so in part 1, actually there were events where this was the sum and then corresponding probability we have found out. So the sum is 2, sum is 3, 4, 5, 6, 7, 8, 9, 10, 11, and I think up to 12. So the corresponding probabilities are, this is given like 1 by 36, right? Few are given and the rest you can write. 5 by 36 and then 1 by 36 is given. Now, what is second part saying? A student argues that there are 11 possible outcomes. So these are the possible outcomes, right? Therefore, each of them has a probability 1 by 11. So a student is saying that there are 11 outcomes. So the probability should be 1 by 11 for each case. Okay. Do you agree? Now we have actually seen that in each case, the probability is different, right?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So these events are not equally likely. They don't have equal chances of occurring. So you will write that the probability is different for every event. Therefore, these events are not equally likely. Okay. And I mean, then we can say hence the given argument is incorrect. Or this is not a correct argument. Anyway, you can write. Okay, next question number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcome. Okay, so if I'm tossing a coin 3 times, now what are the outcomes? So I think we have discussed these, right? The
Yes,
possible
ma'am.
outcomes. Okay, so these are the outcomes that all are head, right? Then we have HTH, then HT, HHT, then HTT, right? Then we have THH, THT, TTH, and then TTT. So 8 outcomes are there. Hanif wins if all the tosses give the same result. Okay, that means in this case he wins and in this case he wins, right? Okay.
Yes, ma'am.
That is 3 heads and 3 tails and loses otherwise. Calculate the probability that Hanif will lose the game. So it's simple, right? Total number of possible outcomes is equal to 8. Now, number of favorable outcomes. Okay, so to lose the game, you have to find. So, favorable
6.
outcomes will be 6. So, the probability of, you can say, lose the game, oh, that will be 6 by 8 or 3 by 4. So, this can also be done like this, like if you can find probability of win the game if you want, like whatever comes to your mind you can do that way. So win the game, so in these two cases he is winning, right? So that means 2 by 8, so that is 1 by 4. So obviously because there are only two, either he wins either he loses, and so the sum of both the probability has to be 1. So the probability of losing the game will be 1 minus 1 by 4. So that also 4 minus 1 by 4, that is also 3 by 4. Both way you can do it. Okay, next question number 24. A die is thrown twice. Okay, what is the probability that 5 will not come either time? So I gave you one table, right? Will 5 will not come either time. So if you just look at the table, so basically it starts like this, 1 1, and then you have then 1 5, right? And then 1 and 6. So I'm not writing all the cases here. Then there's a column where you have 5 1, and then so at least the 5 cases I'm writing. Then you have 5 and 3, then 5 and 4, 5 and 5, 5 and 6. So this you have combinations, right? And this I should write 2 5, then you have 3 5, then you have 4 5, and then you have 6 5. So this is how it looks. Now they are saying you have to find the probability that 5 will not come either time. So let us see how many times 5 is coming, right? So number of cases where 5 is coming. How many cases are there? So you have 6 this side, right? And then you have how many this side?
5.
5 only. Otherwise, this will be double counted. So you have to count it only once. So 11 cases are there where 5 is coming, right? So that means number of cases where 5 is not coming. So total cases are 36 and minus 11. So that gives you 25. So the probability that 5 will not come either time it will be 25 divided by 36. That's it. Now, second part of this question is actually this question is important, right? 5 will come at least once. Right? So first of all, you have to understand the meaning of at least. So I just want to explain the two words. So there's a word which is called at least. And in some cases, you can come across a word which is called at most. What will be the difference? Right? So if I'm saying at least 5 and if I'm saying at most 5, okay? In the case of two dies, I'm taking this case, right? Now, at least 5 means this is the minimum limit. Right? And at most 5 means this is the maximum limit. Right? So at least 5 means 1 5 has to be there. So at least 1 5 has to be there. More than 1 5 can also be there. Can also be there. I mean, not can, I mean, they will be there. Okay. More than 1 5 will also be there. So you understand? This is the minimum limit. At least means at least one has to be there. More than one can also be there. So that means these cases where you have only 5, let's say 1 and 5, right? Then you have 2 and 5. Then you have 3 and 5. Then you have 4 and 5. And 5 and 5 will also be there, right? And then 6 and 5. And yeah, okay.
Yes, ma'am.
No, there will be more. I think 11. So one side I have written and then come to the 5 row. So you have 5 and 1 combination, right?
Yes, ma'am.
I mean, this one I have written and now you go to this one also. So you have then 5 and 2 will be there. Then you have 5 and 3 and 5 and 4. So 5 already written and the next will be 5 and 6. So how many? So you again have 11 cases, right?
Yes, ma'am.
Yeah. Now, if I talk of at most 5, that means this is the maximum limit. So that means just want to write it in short. It will have cases where there is no 5. It will also have cases, I mean, where there is no 5, right? So this is the maximum limit of 5. So maximum limit of 5 is 1. Like at most 5 has to be there. If I say 5, so at most 5 has to be there. It can have 5 also. Understand?
Yes, ma'am.
Yeah. So that means it will have cases like, I mean, all these cases will be there, right? But this case will not be there. So 5 and 5, this will not be here because it is crossing the maximum limit of 5, right? But this case, for example, 2 and 4, this will be there. It is having 5, right? Or you can say 5, right? So this comes under at most. This will not come under at most. So I hope it's clear what is at least 5 and at most 5.
Yes, ma'am.
Okay. So if I come back to my question, so at least once means number of favorable outcomes are how many?
11.
11. Okay, so that means probability that 5 will come at least once. So they are important words, right? At least and at most. 11 divided by 36. And yeah, this will be there, right? This kind of case will be there. This kind of case will be there. Okay. Now, next question number 25. Which of the following arguments are correct and which are not correct? Give reason also. If two coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, and 1 of each. So if 2 coins are tossed, so first of all, the outcomes are 2 coins means head, head, right? Then 2 tails, and then H, T, and TH. So basically, there are 3 types of combinations. One is having like both heads, then both tail, and like one of them, right? Each, one of them each. Okay.
Yes, ma'am.
So therefore, for each of these outcomes, the probability is 1 by 3. So according to the question, the probability should be 1 by 3. So let us see. How can I write? Like both head, right? If I'm taking this case where I'm having both head. So number of favorable outcomes are how many?
1.
Only one, right? So the probability of both heads will be 1 and divided by 4, right? Which is actually not equal to 1 by 3. According to the question, it is 1 by 3. Similarly, if I take both tails, again, the number of favorable outcomes, it is
Ma'am,
again,
but according to the question, the total number of events will be 3, right?
no, according, see, two heads, two tails, and one of each. So basically, like this is one case where both are head. This is second case, and the third case is either one of is head or like it can be head, it can be tail, it can be tail, it can be head. Like this is another set of cases, and they are saying for each of these outcome, the probability is 1/3.
Okay, ma'am.
Yes.
Yes, ma'am.
So both head case we have seen, which is actually not equal to 1/3. Now let us see both tail cases. So favorable outcomes are again 1. So probability of both tails is again 1/4, right? Which is not equal to 1/3. And like one head and one tail. So it is saying one head and one tail. So it is not saying like first one has to be head or second one has to be head. So that means these both of them will be your favorable outcomes, right?
Yes, ma'am.
So number of favorable outcomes in this case are 2. So probability is one head and one tail. This will be 2/4, which is 1/2, which is again not equal to 1/3. So we say, therefore, argument is incorrect. Now, second part. If a die is thrown, there are two possible outcomes. First of all, what are the cases if a die is thrown? So you get 1, 2, 3, 4, 5, and 6. So
Can you
any
just once show the previous page?
okay.
Okay, ma'am. Thank you.
Right. So I'm throwing a dice. So these are the possible cases which can occur. So only one dice, right? So either I get 1, 2, 3, 4, 5, or 6. Now, um, there are two possible outcomes, an odd and even number. Therefore, the probability of getting an odd number is half. So odd number, how many cases are there? Like among these, the odd numbers are 1, 3, and 5. So the number of favorable outcomes is equal to 3, right? So the probability of odd number will be 3 cases divided by 6, which is half, which is correct according to the question. And
Yes, ma'am.
yeah, so according in the argument, it's written only odd. If you want to find even also, that also you get half. If you want, you can find it out. So again, you have 3 even numbers. So this is again half. So therefore, the argument is correct. So I suggest you that you do more questions on especially this kind of questions where 2 dice or 3 coins are tossed, and at least at most type of terms are there. So in RD Sharma, I think you will find many questions like that. So please try to do them on your own and then check your answers in the book. And also please try to write the formula in every question. I skip it, but you have to write at least the formula for probability and then find it out. Okay, Harsha, like when are your next exams now?
Ma'am, I have my midterm on 17th.
17th of October.
Yes, ma'am. Ma'am,
Oh,
16th.
okay, 16th. Okay. So can you just tell me the syllabus once again of maths?
Ma'am, quadratic equations,
Hmm.
arithmetic progressions,
Okay.
triangles,
Right.
and coordinate geometry.
That's it. Okay. So let us do some questions on coordinate geometry now.
Okay, ma'am.
I think I should do. See, you already know the formulas, Hamna. Right? Do you remember, or should I?
No, ma'am, I remember.
You remember. So just 1 minute. I'm sending you a worksheet. Actually, I just found it on the net. So just I just want you to practice some questions, and we can have a discussion on it. Mm, okay, I'm just sending you, and you please start doing it. And when you get stuck, so we will. So see, it's not a Learnivio worksheet. I couldn't type it. So for the time being, I'm just using something which is available. Uh, because the objective is to practice questions. Yeah, Harsha, have you got it?
Yes, ma'am, got it.
Hamna. Yes, Hamna, I've sent you two. So you do it, then I'll ask you answers, right? Randomly. So please keep doing them. Then you can match the answers with me. Yes, Harsha, any problem in any question?
No, ma'am.
Hamna, are you doing it? Okay, I'm just telling you some answers so you can match if you are right or wrong. So the first answer is like A part, it should be 13, right? B part should be 2 under root A square minus B square.
Ma'am, minus.
Oh, sorry, plus. Yeah, sorry. Then second, okay, this was 1. Now second answer is, oh, sorry, 6 or minus 10. Then next you have to show basically. And then question number 10. The answer has to be 11, 2.
Ma'am, can you solve the third one?
Okay, third question. If the points, that means 3, 2 and 2 and minus 3, if I just call them A, B, are equidistant from the point xy. Okay, so C is the point xy. Show that, you have to show that x plus 5y is equal to 0. So it is given that AC is equal to BC, correct?
Yes, ma'am.
So I'm just taking square on both sides. So just avoid the under root. So that means x2 minus x1. So x minus 3 whole square plus y minus 2 whole square should be equal to y plus 3 whole square. Am I right?
Yes, ma'am.
So you just expand the bracket a minus b whole square. So a square minus 2ab, that means 236x plus 9. Now plus y square minus 2ab, that means 4y plus 4. X square minus 4x and plus 4. Y square plus 6y and plus 9. So x square both sides get cancelled out. Similarly y square. Here you have minus of 6x and then minus of 4y, and 9 plus 4 is 13. Now here you have minus of 4x plus 6y, again 9 plus 4 is 13, so again 13 cancels out. So if you bring everything here, minus 6x and plus 4x, then you have minus 4y and minus of 6y is equal to 0. So minus of 2x and then minus of 10y, right, is equal to 0. So just take minus 2 common. So x plus 5y is equal to 0. And bring this minus 2 in the denominator. So x plus 5y is equal to 0.
Okay, ma'am. Ma'am, in the fourth question, it is given they're collinear and we should prove them.
Yeah. Sorry, which question you're saying? Fourth question.
Yes, ma'am. Like they're already given collinear, or do we need to prove them?
Show that the following points are collinear. No, you have to show that they are collinear.
Okay.
So A, B, C. So that means you can check the distances between them. And the sum of two distance should be equal to the third distance. So in that case, they will be collinear.
Okay.
Yes, Hamna, any queries? Hamna is gone, I think.
Ma'am, AB plus BC should be equal to AC, right?
Yes, Harsha?
Ma'am, AB plus BC should be equal to AC, right?
It's not necessary. Like you have 3 points, right? So I don't
Yes.
know which one is A and which one is B. I don't know. But ultimately, so just let's say this is like BCA. It's like this, right?
So we can try all the three possibilities, right?
Yeah, you have to calculate all the distances. Like, mm, yeah, the distance AB you will find, the AC distance and BC distance. Is there any other case here? No?
No, ma'am.
Yeah, so you have to check like the sum of two distances should be equal to the third one. So let's say you are getting, for example, BC is equal to AB plus AC, like this you are getting, right? So that means your points are actually like this is your B and this is your C and A is falling somewhere here.
Okay, ma'am.
Yeah, so it's just a name, right? ABC is just a name. It can fall anywhere. We don't know exactly.
Okay, ma'am.
Yeah, okay. So some questions you have done, Harsha, right? So now I'm just giving you question numbers which you have to complete. So question number 5, then do 6, 7, 8, 9. Just leave 10th for the time being. I'll discuss it in the next class.
Okay, ma'am.
Then you can do 11th. 12th also you can do. 13th, 14th. Yeah, so do up to 14th, right? After that, I think we can have discussion and then we can do.
Okay, ma'am.
Okay, then I'm ending the class. So can we have a test also in the next class of coordinate geometry?
Okay, ma'am.
Okay, I'm not sure. Like I can give you a worksheet also in the class, or it might be a test. So be prepared for it.
Okay, ma'am.
Okay, right. Bye.
Thank you, ma'am.
Yes.